Let's take a look at another way to write first-order linear differential equations. We know that a first-order linear differential equation can be written as a of x times y prime plus b of x times y equals c of x. From looking at an equation in this form, we can see that it is first order because the highest derivative term is the highest derivative, y prime. We can also tell that it is linear because the highest power of the dependent variable y is 1. Let's use this equation to find the standard form of a first-order linear differential equation. We can put the equation into standard form by dividing both sides by a of x. We then define p of x to be b of x divided by a of x and q of x to be c of x divided by a of x. The standard form is then y prime plus p of xy equals q of x. There's nothing special about the names x and y, so we can reverse the roles and have x be the dependent variable and y be the independent variable. Let's try an example of this. We want to rewrite the equation dy over dx equals y cubed over 1 plus xy. Here is a case where the roles of x and y are reversed. The equation is not linear in y because of the y cubed term, but it is linear in x. Rewriting the equation to highlight this gives us dx over dy equals 1 plus xy over y cubed. Remember that dx over dy is the same as saying x prime, or the first derivative of x with respect to y. On the left side of the equation, we'll rewrite dx over dy as x prime. Then, working on the right-hand side of the equation, separate the fraction so we can simplify. This gives us x prime equals 1 over y cubed plus xy over y cubed. Now, simplify to get 1 over y cubed plus x over y squared. Notice that this is starting to look more like the standard form. In this case, we have p of y equals minus 1 over y squared and q of y equals 1 over y cubed. To get all the x terms on one side, subtract the term x over y squared from both sides. Therefore, we can rewrite the equation in standard form as x prime minus x over y squared equals 1 over y cubed.